And Namaskar everyone. This is H.G. Kulkarni, Associate Professor retired from DKT's Textile and Engineering Institute, Chalkaranji. Friends, we started to discuss on the Comber Preparatory and last video I uploaded, you must have watched. Those who have not watched, their friends have not watched, just please share this thing with them. Actually, when I began that presentation, I stated that prior to that, I have completed up to carding. But in reality, actually, it was an oversight. And later on, I realized that I have completed up to drop frame. And in that drop frame discussion also, I have discussed about the two routes, that is one carded route and combed route. So, we'll begin today's discussion. The last we stopped at discussion on sliver lap. Now, while mentioning some of the renowned manufacturers in this, I have discussed some sequences. Those are, for example, say Ritter. Trusler is also involved nowadays in making of this, and Indian company, that is LMW, Lakshmi Machine Works, Coimbatore. They are the pioneers, you can say, as far as India goes. So they have their own sequence also. Entire line of them is different. So we'll begin. Overall, I am taking some outline. As you are aware, I am discussing the outline here. So we'll go ahead in this. So next is the ribbon lap machine. Now ribbon lap machine actually follows the sliver lap machine, and we did conclude in the last presentation on the passage of material through the sliver lap. Now at that time I had discussed also with you that various sequences are there, and as far as the lap preparation goes for the comber, this sequence, sliver lap and ribbon lap, that includes two passages in between card and comber. The reason for that also I have discussed with you. So let's begin. Whatever the sliver lap is prepared, that's one sliver lap prepared is placed on the lap rollers of the ribbon lap machine. So this is lap is fed here, and this particular diagram what we are seeing here, that diagram actually is a cross section cut view of this machine. Entirely one cannot take, actually there are two sections of this. I have combined here two sections together, so it will look like this one. Actually it will be there, one side the feeding is there, and the other side the delivery table and winding mechanism will be there for this machine. So this is a combined view of the cross section of the machine. So this lap is fed, two lap rollers are there which are serrated or grooved, you can say, and on them these lap rollers are positively driven, so that whatever lap is placed on them, that will be unwound, and then the supporting roller is there, and then directly that lap, each lap is passed through a drafting system. So for especially for the ribbon lap machine, 6 heads were there in the conventional machines. 6 heads means the same passage was there 6 times repeated across this cross section, and all drafted waves coming, like in the drafting system the draft was given, and these waves will come on this curved plate, and then they will be coming on the table, the delivery table, steel polished table. On that, two of such drafted waves will be combined, and then one lap will be wound. This is the overall overview of this passage. Now we'll discuss about this one. The lap rollers will unwind this lap that is supported on this roller, and then directly that will enter into the drafting system. This is a 3/4 drafting system. So a symmetric drafting system. This is three top rollers are there and four bottom rollers. Of those four, as I have discussed in the sliver lap machine also, basically middle zone, actually middle zone is split into two zones. Actually this forms one zone, and here you can say a neutral zone, and this forms another zone. So like that this arrangement was there at that time. And first brake draft was given. This is a large roller, middle roller, top roller, and that is supported on two small rollers relatively. Their diameters also have been mentioned here in millimeters, of course. And then that in the main zone, this was the brake zone. Then you can say, one can say, the neutral zone, where better fiber control could be achieved. And then comes the main zone, and then a web comes, a drafted web comes. This is a very delicate web actually. Just like in front of the carding machine, the web is there. This is much more similar to that. And then what will happen here is, why this second machine is used where drafting is there, here reversal will take place. Here reversal will take place. Whatever the trailing fibers were there after card, they have become leading on sliver lap machine, and they are delivered as it is, as they were, and then they become now trailing hooks as far as the fibers are concerned, the hooks are concerned. And those trailing hooks now will be straightened here because their front end is now straight, and that is captured in the fast moving next roller in the drafting system, and the back end gets gripped against that, so it becomes straight. And such web, oriented web, is coming here, and such two each the webs are combined together in the calendar rollers, table calendar rollers. They are highly polished steel rollers, and then each of these will go on combining. All six webs are combined together, and then there is a pair of delivery calendar rollers. Delivery calendar rollers. They are again large in size, very heavy, self-weighted. No external weighting is used on them, and then they will condense this web, and that web is wound onto the with the means of shell rollers. And both of these shell rollers are moving in the same direction. The lap will be wound onto them. Simply supported spool is there on this, and then the lap gets wound. It attains certain diameter, and then these dimensions, width, diameter, etc. already I have discussed with you. So then this lap is ready to be fed to the comber machine. So this is the passage of the ribbon lap machine. So going ahead in this is the view of the ribbon lap machine. One can say here the sliver laps are placed. Each of the sliver lap is drafted, and it comes onto the delivery table where calendar roller and scavenger roller, etc. they are there. Scavenger roller is that which keeps the top roller clean, and each of this web gets combined. It is getting combined here, and then it will go ahead, and at the delivery side one has a spool and winding mechanism for this. For this kind of a machine, they used to use mechanical counters till certain diameter is attained. Up to that, the winding was going on, and once that diameter is attained, the counter has counted those many revolutions of the shell rollers, then that will stop, and manually this lap was taken on the delivery table. Here you can see here OKK brand of this machine, and then it will be taken ahead onto the comber machine. So this is a combination of this. Actually, they used to say in those days, one sliver lap machine and one ribbon lap machine was capable of feeding six combers. So production balancing they were attaining through like this one. And the draft given on this machine is approximately around 6. So why? Because 6 doublings are there, so 6 of a draft will be given. 5.8, 5.7, 5.8 draft is preferred actually. That is worth, means it is worthy to go for 5.7 to 5.8 of a draft. Slightly that draft should be lesser than the nominal draft, and then you are satisfactorily getting the lap that is produced here. So this is how this particular machine will function. Now going ahead in this, one can say have a close look at this. Actually, this is the opened drafting unit here, which has a um, roller clearer, rotating roller clearer for the drafting system, because lot of web fluff generates here on this machine. Though the speed of the machine is less, but still the loose fibers, floating fibers, one can say in the drafting system, they will try to fly in the department. So to prevent that, this flannel was used actually. That was attracting the fibers, and then later on it was either through suction the caught fibers were taken, or the worker will stop the machine at certain times after certain intervals, and then this flannel will be cleaned, drafting system rollers will be cleaned, and then this is the routine practice on this machine. This was the same kind of a practice on the sliver lap machine also. So this web, one can see here that web will come. This is the web plate or fleece plate they say, and then it will go on the delivery table. And after certain webs, the calendar rollers are there, small calendar rollers are there. They are again having covered with the sort of a flannel. So again, no fluff should go ahead in this. So the effort was to prepare a very clean only lap that can be fed properly to the comber machine. So this kind of a thing was thought of on these machines. They had these machines, sliver lap and ribbon lap, both the machines, they were equipped with mechanical stop motions. Mechanical stop motions were used. Any web was broken, not present, and then the signals were there, red, yellow, green, etc. The signals were there in the headstock, or where the drafting system is there, or at the delivery side where the winding and doffing of the lap takes place. So these kind of mechanisms they were thought of. The drafting rollers were externally weighted sometimes. At that time, the spring weighting was just about to begin, so they used to use the dead weights on certain machines, and then later on the spring loading that has come actually. So this kind of a thing was there in case of the conventional sliver lap and ribbon lap combination. Now this is the gearing diagram of this, how the rollers are driven. Only essential parts are driven. One can say here the feed rollers, then the drafting arrangement, and there were provisions for changing the draft also. These wheels were acting as change pinions. One can see here change pinions are there here. If this is changed, drive was generated from, actually drive was distributed from main front roller, main bottom roller, main bottom roller, front bottom roller, that is, to the last roller, and in between that was derived from the last roller. So you have split up of main draft and brake draft, something like that. And from here itself, through sprocket, chain drive was given to the lap feed roller. And then from there itself, the central driving shaft central shaft. The drive was given to the table calendar rollers also, delivery calendar rollers also, and then to the shell rollers. So both the shell rollers are positively driven. So one can see here one pinion is there in between. Sorry, two pinions are there in between. So that will make the roller to rotate in the same direction. So this is how the drive distribution was there. Probably we have not seen the drive distribution for the Slivolab machine. More or less the same kind of mechanism also works on the Slivolab machine. Now these are the proper diagrams of LE 2 by 4A, ribbon lap LE 4 by 1A, etc. etc. So what I have stated that Lakshmi Machine Works also is there, very aggressively involved in production of this all these series of machines. So that one can see here. Again, this was some kind of thing was discussed earlier, but again, just have a revision of this one. Sliver lap, ribbon lap combination, total draft around 9, doubling 120 to 124. Actually, more doublings were there, sliver doublings were there on the sliver lap, and 6 only doublings are there on the ribbon lap machine. Only 6 doublings, they were there more on the sliver lap machine, and comber lap was produced 60 grams per meter. Leads to lap irregularity due to roller slip. This was the basic problem in case of this machine, these machines. Now here you can see classical method, card, sliver lap machine, ribbon lap machine, comber and post comb draw frame. In draw frame, I have thoroughly discussed about why one more draw frame is there. Whether you have combed yarns or even blended yarns, this post comb draw frame is there. That has a function to do that because comber generates what is called as a piecing wave. To overcome that, again once we discuss the comber, again I will try to throw some light on this one. So that makes it mandatory to use a post comb draw frame, and which levels whatever the piecing irregularities are there which are introduced by the comber. Otherwise, comber is a highly classical quality tool. I already stated this thing. Comber is a very high class quality tool, though it works on indirect principle, but it is a very high class quality tool. Actually, it is a quality tool when we say at that time we presume that that quality tool senses and acts, but that kind of a thing is not present. Even in today's combers, some modifications have come on today's combers, but they are not very highly say sensitive to tackle small variations, either which are induced by that machine or which are incoming. So kind of a thing is there like this, but still it is a quality tool. One has to admit that fact. Now another sequence is draw frame superlap. Already I have told Marzulli, they actually introduced the superlap machine, and LMW also they have the kind of a superlap machine. Draw frame, they have a combination of draw frame and lap former. So total draft in this combination is around 30, doublings are 480. Draft, one can say draft is highly increased, but at the same time as compared to the old combination, doublings have been also increased manifold times, at least twice. So doublings were 120, one can say it is 480. So manifold times it is increased, and that induces the regularity in the lap produced from these particular modern sequences. This is mediocre sequence, one can say. conventional, mediocre or medium type, you can say medium generation, and draw frame Unilab or Omega Lab is the very latest sequence in this. So here lab fed to the comber is much more uniform as compared to the this particular sequence on the basis on the grounds of increased draft increased is liable to increase some irregularity. One has to remember this thing because it is likely to have roller slip that I have discussed in the draw frame. But since the doublings are also more, and what we require to feed to the comber is a very increased mass material. We cannot feed, I already have discussed that we cannot feed a sliver to the comber and produce a sliver. It is impossible. So, heavier lap, they are produced. Cross section wise improvements are there. Lengthwise improvements are there. Cross section and length, both ways, the regularity is highly improved, and that is why the quality that is produced from comber has also gone up. Now, latest sequence one can say earlier they introduced, later people introduced Unilab. Now it is Omega Lab. Total draft is around 10 to 30. It depends what kind of hank you are producing. Already I have told which counts are normally produced. You require around 14.14, 0.16 to 0.22 of a hank, sliver hank, for going for combing. So one cannot go for 0.10 hank of the sliver or 0.13, 0.14 hank of a sliver. Normally we go above 0.15 to 0.22 of a hank of the sliver, and then correspondingly lap hank we will become sliver lap if it is there, it will become 0.14, 0.014 to 0.022, 0.014 to 0.022. If someone recalls what lap is produced in the blow room, of course nowadays no one produces the lap in the blow room line, but that lap was having hank of 0.0010 to 0.0020, that for coarse count to fine count. So likewise the differences are there, and here of course doublings are 144. Lap former stage only tension draft about 1.03 to 1.1. Only here now that drastic change they have made. In the draw frame stage, lap former stage, that is only tension draft, and tension draft one can remember here 1.03. This is going to be very useful in the speed frame and ring frame also, that how much tension draft we have to give. This is a very important thing here. And then give whatever draft, rest 10 to 30 means only this much is given in the first draw frame, one can say. Rest is given in the on the Omega lap or Unilap machine. So that, and of course moreover their doublings are also more. So there we produce a very regular material. Now here one can see the sequence, changed sequence, one can say. Card is there, then draw frame, then the superlap, and then the comber and post comb draw frame. This is post comb draw frame. So this is how these sequences are there, and the draft distributions in the textile mill penning and organization. Normally, what I used to teach my students, they know this thing. These things are going to be very useful, and overall, not as a subject also. I am thinking of going for preparation of the textile mill penning and organization presentations also. Once I complete the outline in cotton spinning, this series, there is that particular thing is in there in my mind, that what I used to teach in that subject, there these particular things are required actually. The machine balancing, the floor space required, the labor required, etc., etc. Various aspects are considered in textile mill penning and organization. It is just like a mill penning organization for other industries also. So that is there in my mind. Let's see what happens. But for the time being, we'll see this what how it is functioning here. Now here this particular arrangement is shown where 3 over 3 system is there and manifold doublings are there. Actually in superlab machine of Marzulli, one used to have a 2 over 3 drafting system, and it was vertical. So this is feeding side, 8 doublings they have shown, and then lap forming stage 2 by 12, 2 by 12, and then a combined lap is produced. Draft becomes 8 24 is 192, and then it goes to the making of the lap. It goes further to the comber machine. So this is how this particular arrangement is condensed and shown in case of this particular diagram. Again, what we have seen is again slight repetition of the same thing. So we'll go ahead. Here some differences are shown. Slaver lap machine drawing frame, slaver doubling lap former. Lap former, what is used on the modern, that is lap former is, one can say on in the LMW side, or one can say in the super lap side also, Marzulli side also. So these doublings are there, draft ranges like this. Feeding material card sliver, here also card sliver. Delivered material drawn sliver, of course, here, and then delivery speed and production. So here that particular difference is shown over here. Again, we have discussed this thing. Extra parallelization reduces comber waste. Again, this particular statement we have to understand. Actually, what we produce on comber, what I have shown the staple diagram in the earlier prior presentation, that is a deliberately taken waste. The disturbing short fibers considered on the basis of cotton mix, they are extracted, they are eliminated. But unnecessary waste, this is mentioned about the unnecessary waste. Other things, the draft, etc., already have discussed. So I am going directly to this particular thing. So unnecessary, what comber might take as waste, that is being reduced because of parallelization of the fibers. One has to understand this thing. Lap leaking problem, inadequate nip removal. Now, lap leaking is kind of a thing that when the lap rollers are unwinding the lap in the feeding side of the comber machine, at that time, if the build of the lap is not solid in the sense, one can say for the time being, some sturdiness is there or not, stability is there or not, rather, stability is there or not. That is a, say, wound sheet of the fibers. Lap is nothing but, in case of what is fed to the comber, is wound sheet of the fibers. So whether it is stable, each layer, one has to understand this. A mattress is there, cotton made mattress is there, what we use for sleeping purpose. How we roll and unroll that one easily, because of course it is covered with a fabric. But here this sheet is only sheet of fibers. There should not be cross linking of the fibers in that sheet. This is kind of a visual inspection. One can see this thing, that whether there is any cross linking linked fibers are there or not when the lap gets unwound onto the comber. Because during winding we can't know this thing. When it is made on the, either it is on the omega lap or super lap machine or ribbon lap machine, we cannot understand whether it is properly getting wound or not. But once it is kept on the krill backside of the comber machine and then it is taken for combing, at that time we start realizing that cross-linked fibers are there, some naps are visually seen, etc. etc. If these cross-linked fibers are there, then comber will face a difficulty in its operation. So this is very important point as far as that. And lap leaking means overfeeding of the lap. That lap will have a slackness, one can say, when it is fed to the comber, which is not a very conducive thing when the comber operation is going on. And nowadays, combers are running at very high speed, 600 800 revolutions per minute of the cylinder, or 600 800 nips per minute as the terminology is there. That high speed of operation of the comber, if this unstable lap is there, inadequately wound lap is there, then it is likely to cause problems in mechanical operation, plus it is going to deteriorate the efficiency of the comber. So that way we are required to look at this particular preparation of the lap to be fed to the comber. Now, of course, I have stated this thing about 30s. Normally, we spin the counts, and this classification of the count also I have discussed: 30s to 60s, 60s to 80s, 80s to hundreds, etc. etc. Coarse, medium, and fine, and super fine, of course, as far as the combing is concerned. So terminologies differ. We are required to adopt them properly at proper in the proper department. Now, superlap machine, just now I have shown the diagram. Here one can see the head, three heads are there. From three heads, the slivers which are prepared on the draw frame, prior draw frame, these cans are fed and they are there on the both sides. So this is the feeding table 1, feeding table 2, one can say, and feeding table 3, because this is nearer to the lap making mechanism. So I am referring this 1, 2 and 3. So from each side, the slivers will come, they will be drafted, the webs will appear, they will be condensed, they will be condensed from each of this head, and that is taken on the delivery table, and delivery calendar rollers also condense that web, and table calendar rollers also will condense that material, and that will be taken to the delivery calendar zone, where again it is further condensed, and then a lap is wound here. So this is the super lap machine 2 or 3, as I have mentioned, because I was remembering that one. I have seen this machine in one of the industries here. I don't know whether Shetkari Cooperative Spinning Mill, Ichalkaranji. I saw that machine when we had gone for the industrial visit there, and at that time I still recall that we had seen a 2 or 3 drafting system there. So this is how this super lab machine is there traditionally. Now this is the particular diagram passage of this. Just now I have explained about this one, and then we have the winding of the lap on the machine at the extreme end. Principally, the operations are same. Either you are feeding in sliver lap, ribbon lap combination, we are feeding draw frame slivers card slivers to the sliver lap machine, and then that lap was taken to the ribbon lap machine, and then it was going to the comber. Here the combination is card draw frame sliver, and then take to the super lap machine, and then go further in this operation. So this is how the functioning of the super lap machine is there. Already the technical details, the draft, combination, etc. we have just now discussed in the prior slides. So I will not dwell on that much. This is the super lap machine, a photographic view of that. In this department, one can see clearly the working of the super lap machine here. The cans, quite bigger cans are there nowadays, and then that will go. This is a very now One can say a quality control mechanism works here on today's machines. The highly controlled, regularized lap will be bound with the modern machine in the modern setup. So this is how the functioning of the super lab machine is there. Again, we have Twizzler's super lab machine TSL1. Now, might be in this particular slide, I am taking the slightly conventional or slightly old type of a machine TSL1, but principally that remains same. Either you have Marzulli machine, Twizzler Superlab machine, or Unilab machine operator, or Omega Lab machine operator, or lab former of the LMW. More or less, principally their functioning is similar. So, and it is not possible to discuss each and every machine individually in detail. So, I am taking only outline here, and that you are aware of that thing. Now, Unilab again is more or less the same machine. Just now I have discussed that it is having nearly the same. Of course, additional whatever say cascading cans and the regular feeding to the system, then controlling the mechanism here while the winding takes place, the drafting takes place, the quality control RIQ bridge is there of the return, and automatic doffing is also there. A certain predetermined length is attained. Digitally controlled devices will count that, and then automatic doffing of this material will take place. No manhandling is involved in some of the optional machines where we insist on robolab and all that arrangement, especially in case of return. I am discussing this thing. These produced labs, so what they have done is integrated manufacturing system return is providing. That is optional for Indian conditions. Of course, that is optional, that one can go for that. And in that system, once the lap is doffed, this is on the carriage. From there, it is transported through the lap carrier mechanism, and it goes on the comber with via robolab. So there again, running lap on that machine and new lap which is placed at the back side, that will go there and it will get integrated in the production mechanism. So the manhandling is reduced in textile industry. One point I have to mention here, 10 to 20%, it depends again. Losses are there, quality losses especially. Someone says yarn quality index, if someone says, then that yarn quality index is likely to get affected by 10% if manhandling is involved. So people are preferring the automated systems. So this is how this particular, there are modifications in handling of the material also. That is again, just now I have stated, that is part of textile mill planning and organization. There more scope is there to discuss such points. So we'll see, let's see about that. This is the same pictorial view. Ritter's Unilap machine. Now here, important parts I will discuss. Say, this is the creel of this machine from where the feeding takes place. So prior to this, of course, draw frame is there, and draw frame cans are, they are placed here. That is number one is draw frame can, and then you go on the feed table 2, and then combine all these doublings coming from draw frame, and they are taken to the drafting system, and through drafting system the Unilap will come. So this is how this arrangement is there. What various functionalities are included in this one. Lap up to 80 kilotex, 80 grams per meter, that is. Of course, it has gone to 100 grams per meter. Draft of, just now prior some few prior slides, I have discussed draft 3.48 to 8.04, spool length 300 millimeters, lap weight up to 25 kilograms, speed 100 meters per minute, and production 480 kilograms per hour. Now it has gone up. It has gone up. Now, very interesting part here is introduction of the pressure bar. I I don't remember actually. I must have discussed the pressure bar drafting system in the draw frame, but here we can see we have a four roller system and a pressure bar in the front zone. A pressure bar in the front zone. Various dimensions are there. Why the dimensions play, what role they play, etc. Drafting roller dimension, their covering, etc., etc., and angle, of course, that already I have discussed in the draw frame, so I will not spare time on that in case of this one. The pressure bar is a raised bar, so it deflects the fibers in the main zone of the drafting system of this machine. And typical winding mechanism is also adopted in case of omega lap. A very typical winding mechanism is there that is adopted in case of the omega lap. So that drafting, the care taken in the drafting and care taken while winding of that lap enhances a great deal the quality of the lap produced on the omega lap machine. That's what the actually the focus is there in case of this particular system. That is in Blue Room, I think I must have told, I don't remember, the Ritter's quality monitoring system, integrated quality monitoring system is there. RIQ, bridge, and all those things are there with Ritter. This picture again indicates about how the feeding is there of the adjoined slivers, and then they are taken ahead. So care is taken basically. Now here the loading is shown. Actually, when the drafting system is there, the draft is given, and then draft 2, draft 3, etc. It goes to the further 4 calendar roller large lap rollers and regulated automatic lap loading. So in case of lap rollers, they have done certain modifications. Just now I have stated that winding mechanism has been drastically improved as far as the omega lap is concerned. This is discussing the same thing as far as the winding mechanism of the winding of the laps rather. One can see the pictorial view of this E35 unilap machine. E36, I think they have introduced omega lap rather. They have introduced in recent ITMA, I guess, servo trolley for, just now I was discussing servo trolley for automatic lap transport. So servo trolley, maximum economy with fully automated servo lap transport, servo trolley, servo lap, and robo lap is there on the comber machine. So this is as far as the transportation of laps is concerned, to reduce the manhandling of the laps. Omega lap E35 advantages. Now this is as far as Ritter is concerned. They claim this thing: gentle fiber guidance, uniform pressure distribution, very high bat uniformity. Bat is nothing but lap, and superior lap quality. Constant winding speed 180 meters per minute regardless of staple length, lap diameter. Now I just now stated that speed has gone up. Effective output of 520 kg per hour. This is about E35 omega lap. Low energy consumption. Most low energy consumption per kg of yarn. This I will discuss when I go to the ring frame machine. UKG, units consumed per kilogram of yarn. That I will discuss at that time. Most economical combing set, 1 omega lap E35 and 7E6575 high performance combers, means one omega lab can feed 7 combers, as they claim, high speed combers. Omega Lab E35 revolutionary combing preparation for maximum productivity and economy. New benchmarks for production speed, etc. etc. The quality built lab, etc. that is been discussed here. Though the speed has gone up, the lab quality has not come down, while it is performing better on the machine itself, Omega Lab machine itself, and plus also it is performing better in the on the comber machine. So this is what is the claim by the Ritter machinery manufacturers. Maximum productivity, economy, low energy consumption, etc. etc. So units consumed, that becomes very important as far as yarn manufacturing is concerned, and especially combed yarns, because here already we have taken 10 to 25%, even in certain cases 35% waste of the fed lot. 35% waste is also taken in certain cases. So to compensate for that, we need to economize the rest of the operation. As far as labor is concerned, electricity is concerned, that is power consumption is concerned, and other activities are concerned, we economize on that, we compensate for this, and we can provide a very competitive price of the yarn while we are selling the yarn in the market as compared to the other competitors. So that way these points are very, these are managerial points, one can say. Characteristic of good lab. Now I will slightly sum up this thing. If a lab is prepared well, in case of carding, if someone recalls, well carded is half spun, well begun is half done, well carded is half spun, and well lap prepared, as far as the comber is concerned, it leads to so many advantages. Performance of the comber enhances. Noil extracted is exact the noil that we intend to remove. The fiber lot we intend to remove, that only will be removed. That is what can happen. Homogeneous, because this can happen because of homogeneous slab build. Bat weight CV is less. Bat weight CV, coefficient of variation of the weight of per meter of the lab. This can be either measured, normally this is measured by a cut and weigh method. Take some 10 readings of the different randomly selected lab spools, and then at different zones of the lab build, some wastage we are required to have for this, and then 10 readings we have to collect 1 meter each, and say calculate what is the coefficient of variation of this. Normally this is below, that has to be below 1. Geometric construction, machine condition, bad breaking strength. Breaking strength again under its own weight. No mechanism is there to measure the bad breaking strength, just like unlike the yarn tenacity testers are there. There is no machine available for this. So under its own weight, normally we presume this thing. Higher productivity, less CV of mass, improved homogeneity, better lab quality. CV percent of lab has to be 0.3 to 0.5%. It is clearly mentioned here. Okay, so this is how it is. We are required to attain this goal. If we intend to have, we want to have the comber to perform better, produce a good quality sliver, and then deliver a good quality yarn, combed yarn, we need to have these requirements, these are fulfilled. No weight distribution, lap hairiness, fiber material, total preparatory draft, comber preparatory sequence, lap build-up pressure while lap. These are the technical aspects. Checkpoints, one can say that material stickiness. This is material stickiness. There is honeydew content that is there in the material, and we are required to conduct one test for that. How much honeydew content is there in the fiber? That governs the stickiness of the fiber to the rollers, drafting rollers especially, or lap rollers or calendar rollers. So this becomes a crucial point there. Then drafting system, room temperature and the temperature and relative humidity that is required to be maintained, avoid lap leaking, no lap damage during transportation, etc., etc. So these are the precautions which are required to be there as per as the preparatory requirements of good lab. Just now we have seen pre-comber draft. Pre-comber draft is increased, the noise level will come down. Noise level will come down. So that's what is there. So this again the same discussion is there. Therefore, with this slide, I think I stop here. And as far as the comber is concerned, it requires a very detailed discussion. So more or less, I hope I have conveyed a very essential important points as far as the comber preparatory is concerned. Any doubts etc are there, you can post your questions in each presentation. In my good capacity I will try to answer them. You can give a feedback also, how far this has become helpful to you. Please provide your feedback also. I am eagerly waiting for that. And has the this presentation and earlier presentations, they are able to understand at least basic some of the operations which are there in the cotton spinning or similar spinning operations, one can say. I am really eagerly waiting for that. Please post your remarks, your feedback, etc., etc. Thanks for watching this presentation, listening to me, and goodbye for today. We'll prepare the comber presentation. I will try to prepare it soon. Thank you so much and take care. God bless you. Thank you.